Okay, today we're going to continue our Unit 0, which has to do with functions. We are beginning section 1.5, which is titled Composition. Before we actually get to the math of this, we need to make sure we all understand the word composition. Okay? So forget math for a moment. If you hear the word composition just in an everyday conversation, what does that mean? It can have multiple meanings. What do you guys know about the word composition? Anyone? What's that? Put it together? What do you mean? I think I know what you're saying. Okay, I think I know what you're saying. Is it Lindsay? Right, Lindsay, what's up? To compose. So what does that mean? To make. I like that. So to make something, okay? For example, you're sitting at this beautiful plastic and metal chair. It is composed of metal and plastic. In other words, we took different materials, we combined them to make this chair where you're sitting, correct? So if I ask you what is this composed of, most of the time you should be able to tell me, right? Now, if we take that into a math perspective and think about what our unit is titled, we're talking about functions, right? And if I tell you composition in terms of functions, what do you think we're going to do? We're going to compose functions. And in order to compose a function, we're going to take maybe two functions, combine them and make one, a brand new function, okay? We can do so by using our four simple basic operations, which is addition, subtraction, multiplication, and division. And that's where we're going to start, okay? So for example, let f of x equals 5x squared minus 2x plus 3, and g of x equals to 4x squared plus 7x minus 5. It says find f plus g. Well, all I'm asking you to do is to add the two functions. So here's what I would do. I would put parentheses, addition, and inside the parentheses I'm going to put the functions, okay? So f of x is 5x squared minus 2x plus 3. G of x is 4x squared plus 7x minus 5. And from here, you should be able to handle it and utilize order of operations, correct? So if I combine like terms and reduce, I have 5 and I have 4, so that's 9x squared. I have negative 2 and I have positive 7, so that's plus 5x, 3 and negative 5, negative 2. Agreed? So I took f of x and g of x and I combined them to compose this brand new function. Okay? That's all really we're going to do as far as the operations go. So now with your partner or by yourself, you should be able to try number 2, number 3, and number 4. So put your cups on red, and when you're ready to move on, turn it on green, and then I'll come back to the video if you're watching this and check your answers, okay? Check your answers, please, and I'm going to talk about number 4 here in just a second. So for number 3, I got 15x squared plus 8x plus 1. And number 4, I got 5x plus 1 over 3x plus 1 as your final answer, where your domain being all real numbers except x cannot be negative 1/3. Okay? I really need to talk about number 4 because I feel like some of us are trying to do more than we actually can. Okay? The number one thing that I see you guys trying to do is I'm going to do it in different colors. I'm going to even do it on red. So this is not what you do, what you don't do. So if you have 5x plus 1, 3x plus 1, I'm seeing a lot of people do this. I have a plus 1 and I have a plus 1, so therefore I'm going to get rid of it. Okay? Now, let's talk about it, why you can't do that. And the way I always remember this, it sounds stupid, but it's like you're on a date and then there's that third wheel, but you can't get rid of him or her. Like, you just can't get rid of that one. It's with you. It's stuck with you because you're the right back. That's about it, right? Now, let's talk about it. Let's put some numbers in here so that it actually, you can see why you can't cancel it out. Let's pretend that we're going to input a number in here for x. You guys ready? So let's pick a number. Somebody pick a number. 2. So if we put 5 times 2, that is going to be 10, plus 1 is 11, right? And then 3 times 2 is 6 plus 1, so 11 over 7. Somebody remember that, okay? If we get rid of the 1, if we just do 5 times 2, that's 10, and 3 times 2 is 6. 10 over 6, is that the exact same thing as 11 over 7? It is not. Can you guys see now mathematically why you can't get rid of the 1? Cool? Now, number 2. I see some trying to do this. Not only do they get rid of that, they get rid of the x's. And then they told me that the answer is 5 over 3. Okay? Alright. It's okay. You're not the only one that has made that mistake. It's the same situation with the 1. Like, because that plus 1 is there, that third wheel, it's like, dude, you're stuck. You can't get rid of it. Okay? You just can't. Let me give you an example, because I feel like you guys see a problem and you're just like, I have to be able to do something. Like, it can't be this simple. Like, it can't just be like me putting these two on top of each other and I'm done. Right? The only type of example that you would actually be able to do something is, let me rewrite a total different problem. Let's say, for example, you had 6x plus 2 over 4x plus 2 per se. Okay? Again, I can't cancel the 2's, I can't cancel the x's. However, here's what I can do. Do you guys notice how on the numerator you have a 6 and you have a 2? So they have in common a 2. So I'm going to, what if I do this? Are you guys okay with that? And then on the denominator, I have 4x plus 2, so they have in common a 2. I can take out a 2, and then I would have 2x plus 1. It is here now, in here I can cancel out the 2's. Because it was a common factor from both of them. Can you factor anything out on our problem? So can you cancel anything out? I hope that helped you kind of clear that out. Okay? I don't know if someone in this class tried to do this, but some classes have been trying to do like synthetic division and long division for the purposes of this. That's if we're all gonna get to that, and that's when we talk about asymptotes, and we'll get there. Okay? All right. As far as simplifying this, have I answered your questions? As far as the domain, that's the other thing where I'm seeing some people having trouble. Okay? Why can x not be negative 1/3? Mary Rose. Okay, very good. So anytime you see a rational function, remember rational stands for ratio. Ratio is another word for fraction. So we have a function that looks like a fraction. Well, you know that fractions cannot have a 0 in the denominator, right? So you're like, okay, if I'm trying to find the domain, everything is going to work except what is going to make this right here, this denominator, equal to 0. So I need to figure out what that's going to be. So if I can take my denominator and set it equal to 0, and I solve for x, I have found out all of the points at which I'm going to have a problem. In this case, it only happened to be 1, right? So that means that I can put anything in there except this one value. Cool? Questions before we move on? Can we perform then addition, subtraction, multiplication, and division if I ask you to do so? Awesome. Okay? Now let's get to the interesting part of composition, which is really the next part, and that's the part that I like. Okay? You can also do composition by using evaluation. Evaluation. So what does it mean when I ask you to evaluate a function? So if I give you a function, I gave you 2 here. If I ask you to evaluate, I typically will say evaluate the function at x equals something, right? So if I had originally asked you f of 5, what would you have done? You would have come here and then you would have said f of 5 equals 5 squared minus 1, right? And then you would have said 25 minus 1 is 24, and that would be your answer, correct? Well, it won't be that simple now. I'm actually going to ask you to evaluate at a function instead of at a value, okay? So here's what I mean. I believe most of you guys, well, I think all of you guys told me that you were here last year or in Frisco, so you used Carnegie. And I believe Carnegie used a different notation than what I have here, okay? This stands for, this little circle here does not stand for multiplication. It is a symbol. Another symbol, Mr. Karen? God, you're killing us, okay? Stands for the word of. So this really says f of g of x. Now, most of you guys are used to seeing it as follows. That's how Carnegie introduced this material to you, okay? I just want to inform that both of these things mean the exact same thing, okay? Now, here's what I'm asking you to do. Notice how previously I had said f of 5, so you would put in 5 for every x. Well, you're doing the same thing, but this time instead of substituting in a number, you're substituting in an entire expression. In this case, an entire function. So if I want to evaluate f at g of x, I'm going to rewrite f of x, which in this case is x squared minus 1. I'm going to put parentheses x squared minus 1. You guys with me? And inside the parentheses, you're going to put g of x. In our case is 3x. If you get that far, I'll give you most of the points. Just simplify so you get full points. So what does this simplify to be? What is it? 9x squared minus 1. Be careful. I heard and I've seen this happen too many times where the student will tell me that the answer is 3x squared minus 1. That's why I keep emphasizing to use parentheses, right? Those parentheses tell you that everything inside the parentheses has to be squared. So that 3 needs to be squared. 3 squared, x squared, okay? Alright, I think that should give you a pretty good representation of how to do this. So you should be able to do number 6, 7, and 8 on your own. So try those, turn to red, and when you're done, turn to green and come check your answers. If you're watching this video, check your answers, pause the video please while you're doing so. Alright, so I showed you how to do composition when you are given a function. When you're given two functions and I show you how to manipulate them algebraically. However, that won't always be the case. Maybe instead of me giving you the actual equation of the function, I give you the graph of the function. Okay? Now, for the purpose of this class, I'm not going to give you a function on its entire domain. I'm going to give you a closed interval. What that means is like from a certain point to a certain point. In this case, I'm giving you a domain between -2 and 2. Do you guys see that? Okay. So you have two functions. You have f of x, which is this bottom graph right here, and then you have g of x. Okay? I am telling you to use those two graphs to come up with a brand new equation, and we're going to call it h of x. And the way we're going to find h of x is by doing what with f and g? Adding them together. Okay? Now, before we do that, you don't have to flip. I'm going to flip to the first page. Let's look at example number 1. We did addition, correct? And I gave you the function. You guys agree? Now, we added those two and we came up with a third function. Let's for our purposes, let's call this one h of x. You guys okay with that? All right. Here's my question to you. If you take function of f and evaluate it at 0, so f of 0 on this one right here, what would you get? Right? So that's 0 minus 0 plus 3, 3. Agreed? Alright, so Jeff, you'll be in charge of remembering that, okay? If we do g of 0, what would you get? -5. Okay, Grant, can you remember that for us? Cool. Now, remember that brand new composition that we did? Let's evaluate it at 0 as well. So if we evaluate it at 0, what do we get? -2. Alright, Siri, can you remember that for us? So -2? Alright, so let's recall. For f, we got 3. For g, -5. And for h, we have, -2. Notice how all three functions, the x value was what? 0. It's the same thing, right? But the y values, they were all different. Agreed? Now let's do me a favor. You said f was 3, and you said, what's 3 plus negative 5? What was your solution? Will that work for any x value as long as it's the same x value? Let's try it. Let's try with another easy number. Let's try 1. Okay? Let's do this one more time. So if we put in 1 right here, so that's 1 squared times 5 is 5 minus 2 plus 3, 6. Parker, remember that, okay?
Yeah.
Alright. If we plug in 1 in here, 4 plus 11 minus 5. Okay, so Francisco, remember that for us, okay? So we got 6 and 6. And for h, if we plug in 1, that's 9 plus minus 2. What's 6 plus 6? So will this work for any x value that we put in there? As long as it's the same x value. So what are we noticing? The x values remain the same, but the y values are changing, right? Keep that in mind. Let's go back to the graph. Look at the g of negative 2. So this point right here is negative 2 comma 1. Agreed? And this point down here is negative 2 comma negative 2. Do you guys agree? You have the same x values. Agreed? While I was talking to you guys, what did I have you do with the y values? Add them for that problem right there, right? Well, in our problem, we're also using addition, correct? So the x values are going to stay the same. What are you going to do with the y values? Add them. What is 1 plus negative 2? So guess what? You're going to have the point negative 2, negative 1 on your h of x. Can you do that for the rest of this graph? So go ahead and try it on your own, and then come back and check your answer. So here's the answer, and I want to just kind of give you a reminder here. Here's how I remember this. This is how it works. You always have the same x, and then you perform your operation on the y coordinate, and that's how you obtain your points, okay, for each x value. Okay, so if you want to write that down, you can do it. If you don't want to write it down, you don't have to. If you remember it, that's fine, okay? So you leave your x alone, and then you perform your operations on the y value, okay? All right, now that you have a graphical representation of h of x, we can answer the questions. It says, using the graph above, find f plus g of 1. So what am I asking you to do? What am I asking you to find? In reality, I'm asking you for h of 1. Do you guys agree? Because h represents the f plus g, right? So what is h of 1? 1. Cool? Use the graph above to find f of g of negative 1. So I'm asking you to find f of g of negative 1. Agreed? If I rewrite it, that's how it would look, correct? Can I use the red graph to answer that question? Can I use h of x to answer that question? Why not? It's not using that function, correct? Do I have a graphical representation of f of g of x? I don't, right? You could come up with one if you wanted, because I've shown you how to now do operations with it. However, you're like, wait a second, I think that sounds a little bit tougher. I can add and multiply and subtract and divide the y's, but I'm not really sure what to do here. And I would agree with you, it's a little bit more difficult. You can't just perform the operations. So in other words, you can't just use this rule with that one. Okay? Now, what I suggest you do is the following strategy. Okay? For a moment, we're going to ignore this red graph. We don't really need it for this problem, but we're still going to use the g and the f because they are in our problem. Agreed? Can we ignore for a moment that this is f of g negative 1? And can we just focus on this part? Can you figure out what g of negative 1 is? What is it? Let's do that. So we know that g of negative 1, if we go to the graph, is 1. Agreed? This is an equivalent statement, right? So what if instead of writing this, I write it like this? Is that the same thing? Right? All I did was come up with this information, and instead of writing this, I was like, well, that's equal to 1, so I'm just going to write it there. Can you see where I'm going with this now? Well, what is f of 1? And that right there is your answer. So that means that f of g of -1 is -1, and that would be your answer. If you wanted to come up with a graph, could you do that? You're going to have to make it multiple steps, right? You're going to have to do multiple of those to come up with all the points, but can you do it? It takes you a little longer, but you can do it, okay? Questions on that before we move on? We're almost done with this section. Yay. No? All right. Let's move on then to our last part. And we're going to do this together because I wasn't very clear on the instructions. I made it too confusing for what I was looking for. Okay? So here's what we have. It says, find two equations f and g of x such that f of g of x equals to hx and g of f of x equals to hx. What am I asking? Does anyone know? Parker.
That if you add and put if you add them together and if you put them, like, plug them into each other, that they have the same result.
That they'll have the same result. Good. Let me explain what I'm saying. We need to have two functions, f of x and g of x. If you were to do f of g of x, you're going to get a result. Okay? If you were to do g of f of x, you need to get the exact same result as you did with the other one. That's what I'm asking. What thoughts? What ideas? Where should I begin? What do you guys think? Michael, what's up? That is a very good strategy. Very, very good strategy. So he says, why don't we create h of x first and go backwards? So instead of working forward and finding out f, g, and then coming up with h of x, what if we come up with an h of x and then go backwards? Now, I'm giving you total freedom to do this, right? Like, I'm not giving you a starting point. I'm not telling you you have to use this, you have to use that. It's up to you, right? So you are creating this on your own, which means that on the test, or on the test, because this won't be on the quiz, I don't want to have different answers unless somehow, some way, very unlikely, you guys think exactly the same. Okay? So, we need to come up with an h of x first. Any thoughts? Matter of fact, I want you to try this on your own. I want you to break your head a little bit before I give you any solutions. Okay? Come up with a function of h of x and then work backwards. Cool? You can do this. I believe in you. Try it. Alright, if you are watching this video, you missed the whole explanation, but here's some examples of what I was looking for. Here's your homework, page 56, and that's the problems that you got to do for that section. Okay, so we got to move on. Second part of today's notes, I actually had a typo for rushing. This is not 1.9, this is section 1.6. My apologies. Section 1.6, it is titled Inverse Functions. Again, another topic from Algebra 2 that you should have already covered, so this should be relatively easy for you. Okay? Inverse functions. Let's talk about inverse functions. What do you recall? What is an inverse function, anyone? Anyone? Lindsay, what you got? I'm sorry? So like the opposite of it? Okay, so that's the word that I hear a lot. So inverse, it's opposite of its function. Okay? Anyone else have any other thoughts? So she said being opposite. What you got, Francisco? Now we're getting somewhere else. Alright, so he says opposite, reciprocal. So not only opposite, but reciprocal. What is the reciprocal, just so that we all are on the same page? So a reciprocal is like, let's pretend you have the fraction 3/4. The reciprocal will be 4/3. So it's like you flip the numerator and the denominator. Okay? Alright, so far we've gotten this idea of opposite, and now we got this reciprocal idea. Anyone else? Nope? Alright. Unfortunately for you guys, I think I know what you mean by telling me opposite, but it's not quite that. Okay? Because when you hear the word opposite in mathematics, we think of like, if I tell you number 5, what's the opposite of 5? Negative 5, right? So it's just switching the signs. And unfortunately for you, that's not what an inverse is. It's not just putting what's positive into negative and what's negative into positive. Okay? The whole reciprocal concept, unfortunately, is not going to apply here either. That's going to apply more towards like finding perpendicular slopes. You guys remember those? Okay, so I love it though. You guys gave me some input, so I like it when you try it, okay? I actually gave you a hint on your notes, okay? And it's on quotation marks. Inverses do what? They undo, okay? That's what I want you to remember about inverses. They undo, and I'm going to elaborate on what that means here in just a second. So a lot of people have that misconception of the word opposite. So I think they know what they're trying to say, but do you guys understand now through the explanation how opposite can be misinterpreted? Okay? Now, before we get to the whole undoing thing, let me introduce you how to find these things, and then you're going to realize how they undo each other. Okay? Take, for example, the function x plus 4. If you plug in 1 in there, you get 5. If you plug in 2, you get 6, etc., right? Are we all okay with that? All we did was just find order pairs. Okay? It says the inverse function of f is denoted as f with that little -1 on top. I repeat, this does not mean f to the power of -1. When you see something like this means inverse of f. Okay? So please don't think that that is an exponent. Why they chose it to be or look like an exponent, I have no idea. Okay, that's just what they chose. Alright, so it says, in order to find an inverse, you are going to interchange the first and the second coordinate. In other words, you're going to take your x and your y, and you are going to switch positions. Notice how you had the 0.15? Well, its inverse is going to have the 0.51. 2, 6, 6, 2, 3, 7, 7, 3, 4, 8, 8, 4. Easy enough, right? X's and Y change. Using that knowledge then, if you have the domain of the original function, that means that you also have the what of the inverse? The range. And if you have the range of the original function, then you have what of the inverse? The domain. Okay? I want you to put a star or box or highlight or something next to this right here, and I want to come back and talk about what that means here in just a second, okay? And this is this whole concept of undoing each other, okay? That's what it means, okay? We're going to come back to this, so I want you to skip to this part where it says to find inverse equations of f of x algebraically. I've provided you with the steps of how to do this, okay? So we're going to do number 1 together. First of all, I'm going to give you a function. So in this case, you have f of x equals to 8x. And it says, step number 1, replace f of x with y. So instead of f of x, it's going to say y equals 8x. Step 2, interchange the x and the y. So instead of y equals 8x, this becomes x equals 8y. Step 3, solve the new equation for y. So this becomes y equals x over 8. Agreed? Step number 4, the new equation will be your inverse equation. And I give you a hint. Remember that you need to write it as such. So if you leave it as y equals x over 8, I'm going to take points off. You need to rewrite this as the inverse of x equals x over 8. Okay? Step number 5 is the most important step here. Okay, so I want to make sure we're all here before I start talking about step number 5. Because you will have no problem doing all this. I have confidence in you. Here's what we know so far. We know that f of x equals 8x. And we think, we don't know yet, we think that this is the inverse. Agreed? We need to make sure that in fact it is the inverse. And the way to do that is by doing step number 5. You're going to verify that the two functions are inverses of each other by showing this. That's the rule that I had you start about it up here, and then let's work it out here. Notice that I have f parenthesis inverse of x parenthesis equals x. And then I have inverse parenthesis f of x equals x. I'm asking you to do what? Last lesson. What is it? Starts with a C. Composition. And when you do the composition, your result should be what? Both times. So that's what we're going to do. Check this out. If I do f of the inverse of x, so that means I'm starting with the outside function of f of x, so that means 8, and instead of x, I'm going to use the inverse, correct? So the inverse is x over 8, so that simplifies to be 8 cancels out, x. Good. Now I'm going to do the same thing, but now I'm going to start with the inverse. Agreed? So the inverse is parentheses over 8, and I'm going to put 8 of x inside there. Cancels out, equals to x. Did it pass the test? Okay. Therefore, that's what that means. Therefore, because f of the inverse of x equals x and inverse of f of x equals x, they are inverses of each other. And that's what it means to undo each other. They bring themselves back to the most simple parent function that we know, which is x. Okay? Alright. I know I've been talking a lot, and I'm tired, and I know, and I can see it in your eyes that you're tired, so we're going to take a 5-minute break, and then we'll come back. Cool? It says, which of the following functions is the inverse of f of x equals 7x plus 4? Well, if you follow the steps on the previous page, what I'm going to do is first I'm going to take this function, and I'm going to switch the x and the y's and solve for it, right? So I'm going to say x equals 7y plus 4. Agreed? And that becomes x minus 4 equals to 7y, which means y equals x minus 4 over 7, right? We can tell right away that this is the inverse function, correct? But just a reminder, you also have to perform step 5. You have to. It's not an option. Okay? So that means that we have to prove that they are. So in other words, I'm going to have to do f of g of x. You guys okay with that? So f, that would be 7 times x minus 4 over 7 plus 4. Correct? At this point, those 7's cancel out. X minus 4 plus 4 is equal to x. So we're good, right? And then I also have to do g of f of x. So g of f of x will be, in this case, 7x plus 4 in parentheses minus 4 all over 7. Agreed? Well, I know that 4 minus 4 is 0. And then I would have 7x over 7, which simplifies to be x. That has to be on your paper. Otherwise, I will not give you credit for that problem. Okay? You would only get, if that problem is worth 4 points, you would only get 2 points if you only did this step right here. Okay? Alright. Questions before we move on into how to do this graphically. Alright, graphically, because we're running out of time, I'm going to just skip to the problem. But basically what this says is to remember that inverses switch the x and the y, right? And that the y equals x is the line of symmetry that we're going to use for inverse functions. And you learned that last year. Okay? So here's what we're going to do. We're going to prove that that line of symmetry works. Okay? I'm telling you that I have f of x equals 4x minus 1, and I'm telling you to sketch it, so I'm going to do that on green. So I know that it has a y-intercept of -1, and I know that it has a slope of 4, correct? So 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. So I can do that without having to really input numbers, and I have a very good sketch of f of x, correct? Alright, for times purposes, I am going to tell you that these are going to end up being inverses of each other, okay? Now, here's my question to you then. How can I use that knowledge to help me figure out the graph if I know that they're inverses of each other? Flip the points, right? So, for example, notice how I had the point 0, negative 1. If I flip the points, that means I have the point negative 1, 0. I had the point 1, 3, so I should have 3, 1. I had 2, 7, so I should have 7, 2, and so on. Correct? So it goes in that direction. And it looks something like that. So that was the green is f of x, and the red is the inverse of f of x. Okay? When you are done with that, I also want you to graph y equals x, but I want you to use a dotted line. So y equals x looks something like this. Okay? So I'll give you a couple minutes, or actually it shouldn't take you that long, to have a sketch similar to what I have here. Okay? Now here's my question. Looking at that sketch and recalling what we talked about symmetry, is this symmetric with respect to y equals x? It definitely is. If I could literally take this paper and fold it along this purple line, you will notice that this red part is going to match this green part, and that this red part is going to match that green part. If that happens, that means that those two functions are inverses of each other. Cool? That's all that it means. So now you know how to find inverses algebraically, and now you know how to use a graph to figure out if two functions are inverses of each other. Okay? Now my question to you is, why are we using y equals x? Why? I think you know. Say it.
Yeah, because when you showed us how they both have equal to x, the inverse.
Remember that test I told you to do? What does it simplify to be every single time? So those of you that already knew this information and you didn't know this, this is why that works. Because of this test, it simplifies to be x. That's why the symmetry is with x. Okay? Awesome. Very good. We're almost done. For our purposes, we're going to skip this. That's just another example of that. I'm sure you can do that on your own if you wish to, or you don't have to if you don't want to. The key is already on the hub if you want to actually check your work. So let's move on to the section where it says one-to-one functions. Okay? And this is pretty much where we're done. Okay? All right. We're going to start right here. Okay? By first discovering what a one-to-one function is. Okay? A function of f is one-to-one if each value of y corresponds to exactly one value of x. That's what it means to be one-to-one. So that means that for every x, there's one unique y, period. Okay? That's all that it means. And that they cannot repeat. So for example, if you think of the function y equals x squared. If I put 2, you get 4, right? But if I also put negative 2, then I also get 4. That's not one-to-one because that 4 is pairing with two different values. Okay? So what I'm saying is that every y has to be to one x value, Okay? Now, is one-to-one, then it's going to have an inverse. Okay? Now, your question might be, well, how am I going to figure out if it's one-to-one? And I'm going to come up here, so I need to rearrange this for next time. Okay? Well, how do we figure out that a function is one-to-one? Well, a function has an inverse, and we know that it has an inverse if it's one-to-one, and we know that it's one-to-one if No horizontal line intersects the graph at more than one point. This is known as the horizontal line test. Okay? You are familiar with the vertical line test. The vertical line test tells you that if you only touch a one spot, that means you have a function. Agreed? Well, the horizontal line test is the exact same thing, but rather than having a vertical line, you're going to have a horizontal line. And rather than it telling you that it is a function, it is telling you that it is a one-to-one function. Okay? So, if we go to number 5, for our sake, I'm telling you to grab this, but just for time's sake, I am telling you that that graph looks something like this. So just give yourself a rough sketch of what I have there. Okay? And let me ask you, will that pass the vertical line test? Absolutely, right? So it is a function. Agreed? Now, will it pass the horizontal line test? Yes. So because it passes the horizontal line test, does this have an inverse? Does this function have an inverse? Yes. So it passes the horizontal line test, therefore it has an inverse. Cool? And therefore is one-to-one, right? Alright, so the last thing, and I'll leave you alone, now that you know how to do that, number 6. Very quickly, because we're running out of time, the graph of y equals x to the third looks something like that. Agreed? Will that have an inverse? Yes, it does. So that would be x equals y to the third, therefore the inverse of x would be the cube root of x. Agreed? And I'm sure you can do that on your own, right? Part B, if I graph it like that, but it looks something like that, will this have an inverse? No inverse. Okay? But look at part C. Isn't part C the same thing as part B? With what exception? You have a restriction. So rather than having the entire parabola, what this problem is telling you is that it only wants this part. If I only have that part, will you pass the horizontal line test? So will it have an inverse? Yes, it will. And you would just switch your x and y's, right? So this will be x equals y squared minus 2. So it becomes x plus 2 equals 2y squared. So that means that the inverse of that function will be the square root of x plus 2. Cool? So technically you can manipulate a function to have an inverse as long as you give me the restraints. Okay? Last thing, and then I'll leave you alone, is this whole concept of even and odd functions coming back again. Last class you learned to tell whether a function was even if it was symmetric with respect to the y-axis, right? You also learned that algebraically if you substituted negative x, it would simplify to look exactly like the original equation. Agreed? Alright, well I want you to look at part B. Isn't that an even function? Do you guys agree? I want you to look here, and you actually have the point 2,2 on this side. Okay? Somewhere in there. I just don't have it sketched correctly. And I'm going to tell you that you have the point negative 2,2 on this side. Just looking at that, can you tell me what's happening? Looking at the 2 points. So if you have an x and a y on one side, what would you need to have on the other side? A negative x and a positive y for even functions. Okay? This is a third way of telling whether a function is even or odd. Of the top, do you see any odd functions on the top? This is odd, agreed? Now let me tell you that for sure you have the point 1, 1 here and 2, 3. Give me just a second, okay? And I'm going to tell you that you have also negative 1, and negative 2, negative 8. So what do you notice? I mean, 2, 8, I'm sorry. If you have the point x, y, you also have the points negative x, negative y. Thank you so much for staying with me, guys. Homework for tonight will also be on that page. Quiz next time. Please study. See you next class, guys.